We know that in a right-angled triangle there's a certain ratio between the sides depending on what the angles in the triangle are. Now the cosine rule says that we can make some generalizations about an angle in a non-right angled triangle and how it relates to the ratio of the sides in that triangle. Now the cosine rule proof relies on taking one angle of the triangle, let's say angle A, and looking at three cases. What if A is acute, right-angled, or obtuse? Now, for simplicity, we're just going to look at the proof for if A is acute, so that you've got a bit of an idea where the cosine rule comes from. We already know that there is a definite relationship with right-angled triangles, and you can look up the proof for obtuse triangles if you like and see that we get the exact same rule. So, just quickly now, if we drop a line straight down and call this the height of the triangle, then we can apply Pythagoras' theorem to both of these triangles. Now to do that, we probably need to name some parts of the triangle. We know that this length here is little b, because it's opposite the big B, but we sort of need a name for one of these lengths. So let's just take this one, it could be either one, and we'll call it x. Alright, so in this triangle here, we could say that x squared plus h squared is equal to the hypotenuse squared. Now the hypotenuse would be little c because it's opposite the angle big C. So we have this. Alright, now making this so that h squared is the subject, we can say that we have h squared equals c squared minus x squared. Alright, now if we look at this triangle, we could say that h squared plus, now how long is this length here? Well, it's b minus x, isn't it? So we've got b minus x, all squared, is going to equal this side. Let's label this a because it's directly opposite angle A. That will equal a squared. Alright, what next? Well, we already have an expression here for h squared. So we can say, instead of using h squared here, how about we sub in something that we know h squared is equal to? So I can rewrite this line using c squared minus x squared instead of this h squared here. For this part here, I can now expand this out and say I've got b squared minus 2bx plus x squared, and all of that comes to a squared. Alright, what next? Well, I've got plus x squared and minus x squared there. They can cancel each other out. And what I'm left with is a squared here, let's write it first this time, is equal to b squared plus c squared minus 2bx. Alright, now what is x? Can we come up with some little expression for x? Because x was a bit of a random sort of length that we made, it's not really related to any a's, b's or c's. Well, sure we can. We can say that the cos of a, this angle here, is adjacent over hypotenuse. So that gives us the ability to make a little expression for x and say x must be c, this is a little c by the way, I should draw that a bit smaller, multiplied by cos a. Alright, so I can now plug that expression in for x over here. I might just rub this out and put it in and call x c cos a. Okay, now this is the cosine rule. And there are two forms of the rule. This is the form of the rule that helps us to find sides. So let's look at what everything means here. We need to qualify our statement here and say where A, B, and C are sides of any triangle, okay, and here we have, so we have A, B, C, and another B and C. Now here we have a capital A. What does that mean? Well, that's an angle, and it's the angle that is directly opposite little a, which is the side that we're trying to find here. So A, B, and C are sides of any triangle, and A is the angle opposite side A. Okay, that helps us to find the length of a side. Now, if we had performed this exact same proof, but using a triangle where A was actually an obtuse angle, we would have come up with much the same working, except that when we found the cos of A, we'd be finding the cos of an obtuse angle, and we know that would be negative. And so in some of the places we had positives, we'd have negatives, they would cancel out, we end up with the exact same formula. So how do we use the cosine rule to find the length of a side in a non-right angled triangle? Well, the things that we need, let's first start by recalling what the formula is to find the length of a side. We have a squared equals b squared plus c squared minus 2bc cos a, and the a has to be a capital. So that means we need three sides that we're interested in. Obviously one of them can be one that we're trying to find. We need to know the other two. And then we need to know the angle that's opposite the side that we're trying to find. So let's see if we have that information. The side we're trying to find is here, and the angle that we have is directly opposite. So we're ready to go. So in other words, this will be our A. So we can start by saying, all right, we'll call it X because it's called X on the picture. It's equal to, now, does it matter which of these two sides is B and C? No, it doesn't, because we're just going to add the square of them, so it won't make any difference which way around they go. And over here we're doing 2 multiplied by 1 multiplied by the other, so it's not going to matter which one's which. So let's just go with 6 squared plus 7 squared minus 2 times 6 times 7 times cos of the opposite angle, which is 40 degrees. All right, so x squared equals, at this point you can reach for your calculator. The other way to do it would be to say, you've written out the formula. Some people might prefer to say x is equal to the square root of all of that. I prefer to just have you do one thing at a time, since this is new. Find x squared first, and then find x by finding the square root of x squared. So let's reach for our calculator now. And I've got 20 and a bit. Now I've written out the full readout on my screen here, but one trick is to keep this in your calculator so that at the next step, when you want to find the square root of this side and you'll need the square root of this side, you can put in square root of answer and it'll come out exact. So you don't want to round it off at this stage. Now I can round off now because I've finally got my answer, and I have 4.5. Now you need your units, and I've rounded that off, so I'm going to state what level I've rounded it off to. Now the last step, refer this back to your drawing and say, does this make sense? Could it possibly be 4.5 centimetres? Now even though my picture is not to scale, 4.5 centimetres seems reasonable. Now if you've messed something up, it will be quite wrong. For example, if you'd accidentally written x equals 20 point something, you might look at that and say, 20 seems a bit big, and then you'll realise, oh I know, I haven't taken the square root of both sides. So always refer back to your picture and ask if it makes sense.